morning, almost afternoon. My name is Ryan Edge, and today I am here to talk about how to product. And the subline or subtag would be being a productive product engineer. So what is a product engineer? A product engineer is just a software engineer who's focused on building a product. So you might be working on a small team, doing consulting or freelance. You could be working for a startup or in a greenfield environment. I've had the pleasure of working with some clients and companies who have had some interesting challenges, ranging from strategy and execution to engineering. And this talk is kind of like a passionate, a passionate take on what things make us productive. So again, my name is Ryan Edge. You can find out everything about me, my socials, Twitter, LinkedIn, blog articles, other talks I've done in the past on ryanedge.page. I like to call myself a full stack developer with a front end lean. I generally say that full stack just means you can be dangerous in some things, but you're really only proficient in one thing. So I generally am really good at building front end applications. I can be dangerous on the back end, but you probably don't want me designing the database unchecked. I build applications for web, desktop, and mobile. I've been building Flutter applications for the last 6 or 7 years. Prior to that, I worked with everything from React to Angular, Knockout, going all the way back to like jQuery. Outside of work, I watch a lot of anime, I watch a lot of movies. My favorite animes are Gurren Lagann, Kill la Kill, and Trigun. And then a fun, I guess, fact I would say is this year I went to my first film festival. It was a horror film festival in New Orleans called the Overlook Film Festival. It's a lot of fun. Right. So what's today's agenda? Today we're going to start talking about developer experience, what it is and why it's important. And then we're going to break down the 3 components of developer experience: feedback loops, flow state, and cognitive load. We're going to talk about why those things are important, define them, and then we're going to talk about some tools, patterns, and practices that we can use to improve these 3 components. All right, so not long ago this year, we had a magical revelation that developers were unhappy. According to Stack Overflow, their 2024 survey, only 20% of developers are happy. I'm sure everyone in this room is very happy at their job, and it's just all those other people outside who are living in pain. But some of the common frustrations are dealing with tech debt or not being able to manage their tech debt, the feeling of drowning in debt, and then the complexity of the tech stack, specifically around building and deploying software. And I say building and deploying, that can be on the back end, front end. It's all sort of all encompassing there. So what does an unhappy engineer look like? Well, using myself as an example, they might be managing everything from front end to DevOps because they're expected to be a full stack engineer. Or maybe they're struggling to balance meetings and maintenance and feature development and deployments, juggling all of these things together. Maybe they're multi-domain. So again, being a full stack developer, having to handle different languages and frameworks and tools. But maybe they're multi-domain from a product perspective where they are expected to be not just the developer or the engineer, but also expected to be the product manager, writing their own tickets, and also the QA tester doing regression tests to make sure that nothing's broken. So this brings me to developer experience. Developer experience encompasses how developers feel about, and value their work. And the idea here is that your happiness directly impacts your productivity. What are the 3 dimensions of developer experience? So these 3 work in tandem with each other. Feedback loops, cognitive load, and flow state represent the components of a good or bad developer experience. And the idea here is that any one of these, having poor patterns or practices in any one of these areas can cause confusion and confusion and friction can cost time and money. And again, these components impact each other to create a productive environment. So, what is a feedback loop? For the class participation, can anybody give me an example of a feedback loop? If not, I can give one. Okay. Yeah, nice. I wasn't expecting a scientific one, but that's yeah, that's pretty awesome. Yeah, so this is a great example. Another example you might say is the process of making a comment and getting an actionable response for that comment, and how much time it takes for you to get an actionable response is an example of a feedback loop. So feedback loops are, in software development, they're just mechanisms that are used to validate and get feedback about the software development process. And just using some more examples of feedback loops. The first one, the wait time that it takes to recompile and test your code changes. So I, again, personally work with both web and mobile. I do a lot of React Native, and Flutter development. And it's very interesting to see the difference of the feedback loop there in like Flutter versus in React Native, where I make some changes, save, and then see those changes presented to me. It's kind of jarring going back and forth. Another example is the wait time for approval or for code reviews. I've worked with colleagues in the past um, who had to wait an entire month to get feedback to move forward on an RFC for something as simple as using React context in an application, which is obviously way too long to be talking about React context in 2024. Or again, the wait time for cross-functional communication. So maybe you're working on a task and you have to talk to design, or you have to talk to the business about the requirements, and the time that it takes to get back to you is another example of a feedback loop. So what are some of the ways that we can shorten our feedback loops? The first one, this speaks more to the development process, is to implement a build and test process, or implement build and test processes. So automating early will help you go fast later. This sounds counterintuitive, but it's been true everywhere I've ever worked. Write tests, not too many, but mostly integration tests. Like, I find those to provide the most value. And written tests give you confidence over the thing that you're building. And then also, like, the same thing, automation, building itself, automating your build itself is a test, right? It verifies that the thing will build and deploy. So again, focusing on automation, focusing on testing as much as possible, this will help shorten your feedback loops from a development process. From a product process, streamline your team interactions. So have meetings, not too many, and mostly have those meetings around goal setting and roadblocks. So an example would be design and planning meetings, implementation meetings where you talk about how you're going to implement the particular feature you're working on, or stand-ups, obviously, for giving your day-to-day status and telling people whether or not you're blocked. I've worked on teams in the past that opted out of the Agile ceremony because they didn't see the value in it. But then at the same time, they couldn't understand why we were constantly missing our deadlines, why we were constantly blocked, why people were running into issues where maybe their stories weren't complete. And it's because, okay, we abandoned these processes that allow us to ensure that these things happen on time. So another process we can do is continuously reviewing our tooling and processes. And the idea here is that the only constant in this industry is change. Don't be married to the status quo. If Agile isn't maybe Scrum's not the right tool for you, so maybe you should review Kanban and see if that's the best way for your team to function. Or maybe you want to do something like the shape-up methodology, which is implemented at Basecamp. But the idea here is that you can be successful without adapting for sure, but can you be more successful? In the same way that we continuously review the maybe the architecture we're using or the coding patterns that we're using, we should be reviewing our processes as well. Right. What are some of the tools that we can use to reduce feedback loops? Well, from an agile process perspective, we talked about planning, refinement, stand-up, these processes that help us communicate effectively and better. There's also project management software that we can use. Linear, Jira, there's a long list. I rarely recommend Jira just because I personally don't like working with it, but it's better than nothing for sure. And then ways or things that we can use to communicate, Slack, Discord, Calendly, setting up sort of schedules around when we're available to meet helps the team coordinate easily and effectively. Okay. So next up, we're going to talk about flow state. And for another class participation question, can anyone define what flow state is? If you can't, that's all right. Did I see a hand? Nope. Yeah. Okay. Yeah. Exactly. So the closest translation for me personally, having played sports all the way up to college, is being locked in or in the zone when you're playing a sport. So again, for me personally, when I trained, when I was playing basketball, taking an hour or 2 hours to make 100 shots is a bad day. Like, I feel pretty miserable after that, versus if it took me like, I don't know, 30 minutes, or if I was really, really in the zone, maybe like 15 to 20 minutes. It's very rare that happens. Right. So flow state is a mental state in which a person performing an activity is fully immersed in a feeling of energized focus, full involvement, and enjoyment. Right. So why is it important to be in the zone? Frequent flow state experiences can lead to higher productivity, innovation, and employee development. And then also, similarly, studies show that developers who enjoy their work perform better and produce higher quality products. Poor flow state can manifest in many different ways. If you've ever used the phrase, there's not enough time in the day, that generally can signify that you're in a bad flow state. Interruptions and delays, poor feedback loops, again, not being able to, one, not being able to get the feedback that you need on time, or maybe two, having too many meetings. A lack of autonomy over work structure, not being able to choose when or how you work. Me personally, I am not effective before like 10:30, so you don't really want me writing code then. Versus like, at nighttime, I'm like in my groove up until like 2 a.m. if I'm working that late. Unclear team projects and goals. So there's nothing funner. These two go in tandem. Unclear team projects and goals or poorly defined requirements. For me personally, there's nothing funner than opening up a user story and seeing no acceptance criteria or maybe no Figma designs. And then, like, again, I have to wear a different hat. So how can we improve flow state? So the first one is clustering your meetings. Batching your meetings throughout the week, maybe you have like 1 or 2 days that are meeting heavy, will allow your engineers, your teams to get in the zone quicker. Avoid unplanned work, scope creep. This is one of my personal favorites. Similarly, there's nothing funner than, you're working on a task and that task was due at the end of the week, and then somebody's hair is set on fire and there's a new set of tasks. It may or may not be important, and those are now due at the end of the week as well. Batching help requests. So this is similar to batching meetings. If you're a engineering leader, a tech lead, or a staff engineer, setting up your calendar in such a way that you say, hey, at these times, I'm available if people need help for things. That's generally what I do. And that just allows you to have dedicated times for yourself to be productive. Again, for leads, managers, giving teams autonomy on how and when they work. So using myself, for example, I work much more effectively in the afternoon and the evening. So I generally try to batch my meetings like earlier in the day so that I can be writing code and be effective during the day. But giving your employees the opportunity to sort of choose their working hours within reason, obviously. And similarly, giving your developers autonomy over challenges on the challenges that they solve. So this is again a within reason item because you have a certain number of tasks that you're required to do in any given amount of time. But allowing developers to choose the tasks that they work on, it gives them a sense of ownership over what they're building. And again, they're going to be happier. They're going to feel more productive in those situations. What are some of the tools that we can use to reduce feedback loops? From a team processes perspective, these are all things that I've either done or implemented myself. So having meetingless days, having dedicated days where you are not expected to be in meeting, nobody's expected to schedule meetings, and you can just work on your tasks. Having sort of AMAs, which stands for Ask Me Anything sessions. So again, this is from the perspective of a leader or a staff engineer, having a dedicated time blocks to say this is when I'm available, or this is when people can sort of join and ask me any questions they might have and get a resolution. And then similarly, having time blocks for maybe saying this is my focus time. You can reach me outside of these time blocks, and you can reach me in these time blocks if there's something really serious happening, but otherwise expect me to just be focusing on the tasks that I need to complete. And then from a project management software, this is going to look familiar again, using tools to define the work that you're doing. Linear, Jira, making sure that you're using them effectively so that when developers start working on their tasks, they have everything that they need to complete that task. And then finally, communication software just in a different way. From a calendaring perspective, again, going back to the first bullet item, making sure you're using your calendar effectively, setting up the times where you're available versus not available, and then techniques you can use to sort of get in that zone. One example that's very popular is the Pomodoro technique, where you set up basically intervals of time where you're trying to focus on something versus having breaks. Right. So the last, but definitely not least item is cognitive load. Cognitive load is how much a developer needs to think in order to complete a task. And again, the idea with all these items is confusion and friction cost time and money. So if you're going to reduce the amount of cognitive load, you reduce the amount of confusion, and you're going to save yourself time and money. There are two types of cognitive load that we're going to focus on for the sake of this talk. The first one is intrinsic cognitive load. This is the level of difficulty associated with the problem that you're trying to solve. And then the next one is extraneous cognitive load, and this is the level of difficulty imposed by outside factors. So things that are not directly related to the problem that you're trying to solve that just impede your progress. So a graph that kind of shows like an idea of what cognitive load is. Maybe you had a developer work on a task and they implemented that task, and most of the code in that task is just the intrinsic cognitive load of this is the thing that I needed to do. And a very small bit of extraneous cognitive load is around the developer's quirks or maybe the fancy architecture patterns that they like to use, things like that. On the other end of the spectrum, you have the code for the task was really, really sminy, really, really small, really tiny, and then you have a ton of code around the developer's quirks. Maybe they wanted to implement some fancy pattern like CQRS or something when they really didn't need it. But here, you're reviewing a lot of code that has nothing to do with the actual problem that needed to be solved. And you're not just reviewing it, you're also going to have to maintain it as well. Some examples of cognitive load continued. So cool complex architectures or architectural patterns, poorly documented code or systems, and I'd also say poorly documented can include not having tests for those systems as well, because tests are a form of documentation. Using fancy libraries or trendy technologies. I'm old enough to have used REST, used GraphQL, and seen like people bash both different ways of using those things. So maybe not jumping on the board for the newest technology just because you love it, maybe finding like the use case for that pattern. And then multi-domain teams. This is again one that's near and dear to my heart because I consider myself a full stack developer, so I generally have to wear multiple hats. So cognitive load is unavoidable. There's no way around it. But the things that we can avoid are the processes and systems that increase the extraneous cognitive load, the cognitive load that's not associated with the problems we're trying to solve. And reducing these reduces waste, improves our capacity to deliver. So again, confusion, friction, cost time and money. We try to reduce those things as much as possible. So we're going to break these down into 3 different categories. This is kind of a bigger item than the last 2. We're going to first talk about like cognitive load from a tool perspective, then from an information perspective, and then from a work process perspective. So from a tools perspective, maybe we're using tools that have a lack of functionality or a lack of stability. So using tools that are too greenfield, that you get a certain way down the road and you discover that that tool isn't the right tool for the job, and then you have to create all of these exotic workarounds because you're using that tool. Maybe there's delays in the feedback that you're getting around the tools that you're using. So I've used tools in the past, open source tools in the past, where when you do have a lack of functionality or stability, getting that feedback to where you can move forward can be time consuming, and eventually you end up having to abandon those tools. And then a big one for, again, for third-party tools is usability and unintuitiveness. And like an example I'll use recently is I've been working with Checkout.com's Frames SDK. And the Frames SDK for web, at least, is not documented at all. So they document essentially how you use the methods, but they don't document how you style things, like you're using an iframe basically, and they don't really document how you style things. So you then have to look at their example code and then sort of retrofit the example code to fit your styling needs. Obviously, this all takes more time than if you were to just tell me, okay, these are the CSS classes that I need to use, and these are the properties that I need to use on this object to be effective. So the next category we're going to look at is information. So maybe, again, you're working on tasks that have incomplete or missing information. Maybe the information is unreliable. Maybe the Figma designs have changed. I've dealt with this so many times where you start working on a task and the Figma designs change while you're working on the task, but that's not communicated to you. And of course, QA is going to look at this, and rightfully so, say these designs don't match, this is a bug. So ensuring that you're using some sort of versioning can kind of help with that. Maybe the information that you need is hard to find. So again, going back to poorly documented systems or poorly documented processes. Or maybe the information is poorly organized. So maybe you're, for me, for example, maybe our client is managing some information in Google Docs and some information in, was it Cody, I think it is, and then some information in Confluence, and then we also have Jira, and finding where you should look for the right information. Again, it's time consuming, it's an extraneous problem that you shouldn't really have to solve. Yeah. The last item that we're going to, information. All right, yeah, so the last item that we talk about is processes. So again, going back to previous slides, a lack of automation means that you have to do things manually, and then those manual steps are going to take time. Ad hoc implementation of processes or tools. So again, using exotic processes in one place or exotic tools in another place is going to increase the cognitive load of maybe a developer who hasn't worked on those things in the past and is now coming to work on those things, and they have to spend a certain amount of time learning how to do those things that are a departure from like team norms. A lack of clarity on how the team works. So Having stories and tickets that maybe some of those tickets have a clear definition of done, acceptance criteria, links to Figmas, but then you open up other stories and they're missing all of those things or some of those things. Not having consistency on those things and not having that process documented is an example of a lack of clarity. And then having some sort of approach to technical debt. So technical debt will never go away, it will only grow. All code is technical debt. You really need to have a process for coming back and improving upon the code that you have written in the past. So how can we combat cognitive load? So taking this from a sort of an architecture, we're going to start with from the tech side. Stick to boring architecture as long as possible. And this quote is from an article I read recently. Stick to boring architecture for as long as possible. Spend the majority of your time and resources building something your customers are willing to pay for. The idea here is that the fear of missing out can directly impact your productivity. This one kind of works in tandem with the previous slide. Let your architecture match your needs and capacity. So multiple functional teams may function better using, microservices. But if you're working in an environment, again, that is like a product engineering environment where maybe you only have 5 to 7 engineers, small startup or greenfield project, then maybe using microservices creates more problems than it's worth. And maybe you don't need microservices because you're not yet operating on the scale where you're handling 100,000 users. Maybe you only have like 50 users. Small teams may function better with monoliths. So again, if you're working in an environment that is sort of monolithic, then you're probably fine with a much smaller team. But if you have like 50 plus engineers, then maybe you're better splitting those teams up into multiple functions or multiple projects. And separating those projects into like a microservices type pattern. And scale your architecture for your demand. So again, like let the business requirement be matched with the decisions you make from an architectural perspective. There's no need in preparing for a world where you have like 2 million users on day one because you don't really have the funding for that world yet. Right. Limit responsibilities or simplify domains. So as much as you can, try to not wear multiple hats if your teams can afford it. Again, being a full stack engineer, my primary focus is on the front end. So I do back end stuff every now and then, but generally when it's something that's outside of my expertise, I hand it off to somebody who's more familiar with the problem that needs to be solved. And the same thing, I wouldn't expect a back-end engineer to build some really complex animation on a page that might take them like months versus it might take me, a week or two. And then similarly, from a product perspective, try to have people who handle the product side, who handle the QA side. Not to say that developers shouldn't do QA, like developers, again, should write tests, but having somebody whose sole focus is quality is going to help you in the long term. This one is kind of a follow-up, evolving your tech stack strategically. So you start with what is well understood and proven. Start with technologies that are well understood and proven. And then you have to make compelling arguments for using advanced technologies or advanced techniques. And you make those compelling arguments maybe using like an RFC process where you say, hey, we were using, React Query to query our, or TanStack Query to query things to on the back end. And for this particular use case, maybe we need Redux. That is a pretty drastic change, so you should put together some documentation that basically will convince your colleagues that you need to use this particular pattern since it's a departure from the norm. Right. Prioritize value over creativity. So there should be a consistent theme here is that your focus is on providing a business value, and it's like we want to use the cool, fun, shiny things because it's fun. But there has to be a business need for using those cool, fun, shiny things. It can't just be, I learned this thing, I read a blog post, or I went to a conference and I want to use this thing. Try to figure out what the business value is, and convince your colleagues, and convince the business that there is like value there. And the example that I would use is that I'm working on a project where it's a Flutter application. We're using Firebase for pretty much all of our authentication, our remote config, all those things. And we've run into some issues where users are getting runtime exceptions because of the versions of Firebase, the native dependencies, being out of whack with the versions of our iOS build versions. And that's a problem that will never go away. That problem will come up every time we do an upgrade, either of our iOS build version or of our Firebase versions. So then the question becomes, how do we solve this? Okay, one potential way we can solve this is removing removing a native dependency in favor of a dependency that's written fully in Dart code, so that we'll never have that native conflict. So that's a clear, there's a business problem that we're trying to solve. Here's a potential solution. Is it worthwhile for us to invest in this solution, or should we just continue to pay the debt of having these errors and then resolving these errors maybe once or twice a year? So this is one that I've been thinking of a lot lately. It's the idea of reviewing your code and your tooling retrospectively. And this kind of came to me like after years of coming back to code that I had written 6 months ago and telling myself that I was stupid for writing it this way and it could have been way easier. I think that it's a good idea for you to just continue to review your code. At some cadence, 3 months, 6 months, a year, maybe you have like a code slush schedule or block of time built into your year that is just time that you can take to refactor your code. But continuing to come back to your code and say, is this the best version of this code? Does this still make sense? Is it easy to understand? Is there an easier way for me to do this thing and remove some potential patterns and technical debt? So paying down your interest, paying down your technical debt, asking yourself, does this code still make sense? And the similar sort of perspective, asking yourself if the tools that you're using still do their job and do it effectively, intuitively, or is there a tool that is simpler that again is going to help you reduce your cognitive load? One that may or may not be obvious is writing clean code. So simple things like limiting the amount of code in a function or file, creating abstractions to hide implementation details. For me personally, I try to create the abstraction after I've seen the code duplicated multiple times, just because I can't think in the opposite direction. I end up optimizing the wrong ways. Simplifying your code, your control flows, doing things like having early exit return statements rather than having multiple like if-else conditional statements. Minimizing your mutable state. This is a big one for if you're building like front ends, because generally speaking, like technologies like Flutter reward you for building things using an immutable state versus mutable state. And then limiting test overhead and mocks. So structuring your code in such a way that you're not required to mock out a ton of things, or you're not required to do a lot of ceremony and setup for your just to test, a simple button click. So example I would use is I'm working on a project currently where we're doing DI using static references everywhere, and that makes it real problematic when you're 5 layers deep in a widget tree, and this button is referencing static DI. It can be really hard. You're basically running the test to see where the DI has failed, and then you're updating the setup. So it creates, kind of a bad feedback loop. Versus if you make the API of the widget obvious and say, hey, it needs these dependencies, or you create a wrapper around that widget that references those dependencies. It makes things a lot simpler and easier to understand. Another one is defining your team norms, and this is something that I brought up on other slides. So enforcing consistent forms of communication, consistent forms of saying how we release, how we test. One idea that I've been playing around with recently, for example, is the idea of using Gherkin for your acceptance criteria, your unit tests, and your test plans. Gherkin is basically a way of describing the test scenario. So given a specific scenario and some criteria happens, this is the expectation. And the nice thing about using this for acceptance criteria is those acceptance criteria can basically be used to generate your unit test and your test plan. So it creates a cohesive, similar language that everybody's speaking from product to QA. What are some of the tools that we can use to reduce cognitive load? So the first one, we talked a lot about automation, so this could be a little bit repetitive, but CI/CD pipelines help us remove extraneous cognitive load because we're not managing things manually ourselves. Using things like infrastructure as code or infrastructure from code, we didn't really talk about like the idea of like manually creating your servers and stuff like that. But from a backend perspective, you can do infrastructure as code, which allows you to essentially automate the process of managing your infrastructure. Or you can take that a step further and use something like infrastructure from code, which is a self-provisioning sort of framework architecture. Some tools to reduce cognitive load continued. So low-code platforms. I generally am from the perspective of use the tool that helps you solve the job most effectively. So everything doesn't need to be an application. From my perspective, everything doesn't need to be a mobile application. Some things can just be a web application. So you have to prove to me first that what we're trying to solve can't be a web app, and then prove that it can't be a cross-platform application, and then we'll go down to a native application. But it's a similar idea here. If you can solve the business's problems using a tool, a simpler tool, then use that simpler tool. In techniques, managing your day effectively. So these, again, are going to look very similar. Some techniques you can use are Pomodoro, the idea of time blocking, so blocking out sections of your time. Eat that frog, which I don't remember what it is, so I'm not gonna I'm not gonna try and define it. And then the action method, which basically, if I remember correctly, is defining like the specific actions that you want to accomplish that day. And then the last one, having heavy meeting days and no meeting days. So budgeting or budgeting all your meetings on particular days, having days where you're just allowed to code and be effective. All right, so let's recap these items briefly. So poor developer experiences cause friction, and friction limits productivity. It should be sort of beating a dead horse by now. Developers want to be productive and provide value. Working in an environment that doesn't allow that will ultimately lead to like poor mental health, and that will lead to worse productivity. Feedback loops allow teams to work quickly. So you can speed up feedback loops by automating repetitive tasks, constantly reviewing your tools and processes, and streamlining your team interactions. Reducing feedback loops and empowering teams can help you improve your flow state. So you can improve your flow state by giving developers and teams autonomy, batching your meetings and requests, and limiting barriers or removing barriers as much as possible. And then finally, removing extraneous cognitive load and focus on the business problems that you're trying to solve. So you can reduce cognitive load by reducing responsibilities, reducing the complexity of the technologies that you're using or simplifying the technologies that you're using, writing clean code, choosing the right architecture at the right time and evolving your architecture over time according to the business's needs. And then you can also reduce cognitive load from a product side on the entire team by defining team norms on how you communicate, what your execution strategy is for the problems that you're working on. And hopefully, reducing cognitive load, improving your flow state, and simplifying the processes that you're using will lead to happy team. Happy team leads to happy products or good products, and good products lead to happy users. And then last but not least, if you'd like to learn more about any of these items, there's an article on developer experience, which kind of started as the driving factor for this talk. Tons of articles on cognitive load. That's kind of become my obsession over the last like 2 years. Some stuff about infrastructure from code versus infrastructure as code. And again, some stuff about how you choose your architecture, how you write clean code to reduce your cognitive load. Any questions? All right, easy crowd. All right, that's everything. Thank you for coming to this talk.